Hello, I can confirm all the information for this is accurate as of Tuesday the 8th of December 2020, and if there are any issues with copyright, please feel free to get in touch. Okay, so this lesson we're looking at endogenous pacemakers and exogenous Zeitgebers. What I'd like you to do for the starter is to do the following revision exercise. Have a look at the keywords and decide which words are missing. Please pause the video and write out or use the sheet if you have access to the sheet. For your extension task, name a case study for each. So in terms of your answers, you should be referring to localization of function and about certain functions being localized in certain areas, such as visual function in the visual cortex, which is in the occipital lobe. In terms of case studies, you could have referred to Tan and Broca with regards to Broca's area, and in evaluating this, you could have referred to Dronka's and the idea that when looking at the lesions on Tan's brain, it did not reach the same conclusions. There are also other examples of localization of function, such as Hubel and Wiesel and sewing the cat's eyes shut. With regards to hemispheric lateralization, that's how some of the neural functions or cognitive processes tend to be more dominant in one hemisphere than the others. For this, you should have referred to Sperry and Gazzaniga and their split brain exercises. And finally, plasticity and functional recovery refers to the fact that the brain can change and develop and therefore can recover function after damage, such as car accidents and strokes. An example of negative plasticity would be phantom limb syndrome. You may have referred to the the practical application of neurorehabilitation. Okay, so by the end of this lesson on endogenous pacemakers and exogenous Zeitgebers, you should be able to apply knowledge to a past paper question. You should be able to state the difference between exogenous and endogenous. You should be able to describe the case studies related to both and evaluate the case studies. So what we're going to do is we're going to kick off by looking straight at a practical application of studies related to these pacemakers and Zeitgebers. So Schwartz in 1995 decided to analyse the results of baseball games. And what he found was that when baseball teams were flying from the west of the United States to the east, in comparison from the east of the United States to the west, they were finding that they were getting a different win-loss record, where in terms of their form, they were losing more times when they were travelling from west to east. And what this means is they were flying against the clock, so were arriving jet-lagged. Okay, so what he did a lot of statistical analysis. He had a look at the jet lag of the teams, and he had a look at the P values in terms of doing testing. And what he found was that over 46,545 games, then there was a considerable trend. So what this meant was, with this information, the teams could use this to adapt their practices. So what happens in terms of changing travelling protocol, a starting team may have travelled earlier to get to their eastern destination. So, for example, if a London-based football team were to play a team in Kazakhstan, they may travel several days earlier, rather, to make sure that the effects of jet lag do not affect their performance. When we're thinking of Schwartz and Czeisler, what's important to discuss are the following things. These are true to real life, so they have high ecological validity. They've been conducted in real life environments. If you've forgotten what Czeisler is, Charles Czeisler was the person who had a look at the phase delay model of shift patterns. Other things to think about is that the idea that people are subjected to the same shift patterns, but there are lots of different factors that can affect sleep, such as personality, food intake, caffeine intake, age, etc. So different people will be affected in different ways, and this is why we cannot make generalizations. In terms of the practical applications, so for example with Czeisler, you could adjust the shift patterns, and you can give melatonin supplements and expose to light fitting with a new time zone. You can have a look at the social cues as well to make adaptations. So what we're doing is we're adapting to the effects of shift work, and we're adapting to the effects of jet lag. People are affected in different ways. Some people are dealing better with the ideas of shift work and jet lag. Some people deal better with sleep deprivation than others. So it's difficult to make generalisations. So with regards to endogenous pacemakers, what we're thinking about here is the things that describe our internal body clocks, the things that regulate our biological rhythms. These can interact with the external environment as well. These are the things that set our internal time, so work with external cues such as light to set our cycles. So for example, in terms of Seif, one of the methodological issues was the fact that he was using a lamp. So, shift work, jet lag. What happens is the internal body clocks end up out of sync with the exogenous Zeitgebers, such as the sun, which can have a far-ranging set of consequences and can affect psychological and mental state. The main endogenous pacemaker, and in your exam you only need to refer to it as the SCN, are the suprachiasmatic nuclei, which are a bundle of nuclei that sit below the brain. In terms of one of the major case studies with regard to the suprachiasmatic nuclei, we need to look at Decoursey et al., whose results were released in the year 2000. So, what Decoursey et al. Did is he took 30 chipmunks, and what he did was he used an electrical process on the suprachiasmatic nuclei to affect them. Okay, so effectively damaging the suprachiasmatic nuclei. What he would do is he would release the chipmunks into the wild for 80 days, and there was a 40% mortality rate within those 80 days. Now, conclusions that he made from this is because their sleep-wake cycle had been affected, they were more vulnerable to predators, for example, being awake when they should have been asleep, or being asleep when they should have been awake. And therefore, the suprachiasmatic nuclei being affected meant that the endogenous pacemaker had been affected as well. In terms of the methodological strengths, he did compare it to other control groups. So, for example, where he held the electrode near to the suprachiasmatic nuclei but not close enough to affect them, and 0% of these chipmunks died. He also found, by just releasing the chipmunks for 80 days, that 15% of the chipmunks died. Therefore, he could conclude that the electro effect on the SCN had caused the effect. One of the other evaluative points is the fact that these are ethical issues. The animals did come to harm during the process, so therefore this can be concluded to be an ethical issue. The final ethical point, or more so the final psychological point, is that this is an experiment done on animals. Okay, because it's an experiment done on animals, it can't be generalised to the human population. Another important study related to animals was done by Rath et al., whose work was published in 1990. So, what he did is he took these hamsters. Now, these hamsters were abnormal in the fact that they had a 20-hour circadian rhythm. So the sleep-wake cycle was 20 hours. And what he did was he took the embryonic cells that were related to the suprachiasmatic nuclei and implanted them into normal hamsters, ones with a 24-hour sleep-wake cycle. What happened when he implanted these suprachiasmatic nuclei cells into the normal hamsters were their sleep-wake cycle shortened to 20 hours. So, therefore, he could conclude that it was the SCN that was causing the adaptation to the sleep-wake cycle. Again, in terms of evaluation, this has ethical questions as it is a study on animals that may cause harm, and also non-human animals cannot be generalised to humans. Now let's have a look at the exogenous Zeitgebers. Now, Zeitgeber is German for time giver, and exogenous Zeitgebers are external factors that reset our biological clocks, and this is known as entrainment. So, for example, Seif's study in a cave showed that his biological clock was running at about 25 hours, which is why it's circadian. It's about 24 hours. So, the exogenous Zeitgebers are responsible for keeping our sleep-wake cycle at 24 hours. So, for example, as a Zeitgeber, you could have light, you could have social cue, such as meal times, etc., and noise as well. In terms of the pattern, different humans have different patterns. Please pause the video and have a look to see what a human pattern typically looks at, although it does vary from person to person. Please excuse the misspelling of the word efficiency on the left. So, if we have a look at the examples of exogenous Zeitgebers, light is the main Zeitgeber in humans. Okay, so it's the main time giver. Now, if we consider it, it can have an indirect influence on the sleep-wake cycle by exerting influence on hormone secretion and blood circulation. And we'll have a look at studies related to light and the effect on the sleep-wake cycle shortly. The other things are social cues. So social cues such as bedtime, meal times, and that should indicate when somebody should be sleeping and waking. So for example, as a response to jet lag, you could have a meal once you get off the flight to adapt your endogenous pacemaker via the use of these exogenous Zeitgebers here. Also, the other factor to consider is human babies have random sleeping and waking patterns when born. However, your circadian rhythm kicks in at about 6 weeks old, and by 16 weeks is normally well entrenched. So let's have a look at the studies related to exogenous Zeitgebers. The first one is Campbell and Murphy. Now, what Campbell and Murphy did was in a sleep lab, he worked with 15 people. Now, whilst they were sleeping, what he would do is he would wake them up and he would shine light on the back of their knees. Okay, now this light shone on the back of the knees was causing an effect in the humans, and what was happening was their sleep-wake cycle was changing by up to an additional 3 hours, which suggests that light has an effect on the sleep-wake cycle. A cycle was not rerun and the experiment was not repeated. In terms of one of the contradictory studies, we can have a look at Miles et al.'s study of a blind man in 1977. Now, this is an idiographic study, so it's a study of one person. So, this blind man had a sleep-wake cycle of 24.9 hours, had no light as a cue, and there were no social cues either because he lived on his own and did not mix with other people. It required medical injections to adapt the person's sleep-wake cycle to 24 hours, so to essentially get rid of the 0.9 hours to make sure that he was in synchronization with the day. So therefore, the light situation related to the knees isn't applicable to the Miles et al. Study, so therefore suggests that, that you can't replicate the results of the above. So that is the contradictory study of Miles et al. Other studies are Klein and Wegman. Klein and Wegman found the circadian rhythms of air travellers adjusted quicker if they went outside more at their destination or were exposed to social cues and the light of their new time zone. So, for example, staying straight away in a hotel connected to the airport is not a good suggestion. What I'd like you to do is to pause the video and have a look at the practical applications of this. You may want to consider productivity, you may want to consider sports, and elaborate on what this finding can do in terms of a practical application. Also, what I want you to do is have a look at the support and research for the role of endogenous and exogenous factors, okay? And you may want to refer to other studies, and also you may want to discuss the methodological issues of the studies that we have looked at so far. As a supplement, it is worth knowing about the effects of the pineal gland, melatonin, and jet lag and the associated symptoms of jet lag. And what you may wish to do is use this information to back up a 16-mark question. Please have a look at the additional knowledge and familiarise yourself. Please pause the video here. In terms of the simplistic nature, it's been argued that there are lots of different contributory factors to the sleep-wake cycle. Okay, so for example, the Yamazaki study, what happened there was they extracted liver cells and kept them alive outside of a human and were to have a look at their activity, and they still followed a circadian rhythm. Okay, in terms of other studies, such as Damiola in 2000, changing eating habits of mice, they could alter circadian rhythms in the liver and leave the suprachiasmatic nuclei unaffected. Okay, so it may be a case that there is not just the one internal pacemaker, and not only the SCN is a factor in keeping the internal clock going. What I would like you to do to prove that you have understood is to read the item that is on there. So read the STEM, make sure you refer to the STEM in your answer, and answer the question related to sleep. please pause the video and attempt the question. In terms of making sure that you've understood this, what would be worth doing is having a look at the studies on here for Decoursey and Campbell and Murphy, trying to fill in the blanks and decide whether it's an endogenous pacemaker study or an exogenous Zeitgeber study. Okay, and then what I want you to do after that is to try and explain what you have just looked at and explain the findings in terms of evaluative points.